Welcome back. My name is Jesse. I am a tutor in Melbourne and I also make a whole bunch of different videos on YouTube now, running through different things for VCE students. I cover pretty much every single subject, so all the maths, methods, which we're going to do today, English, all the sciences, business, accounting, economics, all those kind of things. What we're going to do is today we're just going to look at tangents and normal equations, which comes up a lot in the methods exam. So if you're studying to sit the VCE methods exam in a couple of weeks' time, or you're in year 11 and you're still trying to wrap your head around it, then this might be pretty helpful. I'm trying to make these pretty bite-sized and pretty quick, so straight to the point, key steps that you need to follow, and then we'll try to do some applications as well. So looking at it, basically all we have to do is define a tangent. A tangent is just going to be a linear line or a linear equation that touches a curved function or any function just once. And our goal is to work out what is the equation of that at a particular x value. It's always going to be strapped down to a particular x value. And so what we can do is we can follow these 5 steps. So for tangents, we first have to find the derivative. We then sub in the x value. So I'm just going to call that a in general terms to get the gradient, right? So remember that the derivative calculates gradients over x. So when you sub in an x value, you'll actually be calculating the gradient of the original function f of x. And so now we've got the gradient of the tangent, we'll call that mt. Then we need to get the y value that goes with that coordinate. So f of a would be the y value when you sub in a into the original function. And then you're going to plug in both your gradient that you calculate and also the coordinate a and f of a into the general linear equation y equals mx plus c. I've just put little t's on them to denote that it's a tangent. And then we're going to solve for the y-intercept c. And then finally, you can rebuild it again. You can put your gradient and your c value back in, and you've got your equation. You can do the same thing with normals. Normals are just a linear equation that also touch the graph, but they may touch it more than once. They are perpendicular to the gradient at that particular x value. So you kind of need to work out at least the gradient of the tangent first in order to get your normals. So 5 steps again, but we're just going to add in an extra little bit. You first get the derivative, you then sub in the x value to get the gradient of the tangent, mt, and then we know that the gradient of the normal is going to be the negative reciprocal, so -1 on that gradient. And then from there you can repeat the steps, but you'll be working with normal values now. So f of a will give you the y value of the coordinate, then substituting your gradient and the coordinate into the linear equation format, solve c, and then you can rebuild. So if we practice that here, a simple example, and then we'll do an actual VCAR example as well, is if we had f of x is x cubed minus 3x, and we want to find the equations of the tangent and the normal at x equals -1. So this is going to be like our a value from the general notes. So step number 1 is find the derivative. So we can do that, and we can get, using our n-1 rule, 3x squared minus 3. So then the next thing is we've got to plug in our x value to get the value of the gradient at that point. So 3 times -1 squared minus 3, which is going to be 3 times 1 or 3, take away 3, which in this case is actually 0. So that is my m tangent. Step number 3 is get the full coordinate that we're actually passing through. So remember that the coordinate that the tangent touches is both on the original and on the tangent line. So we can solve it from the original, and then that's why we can use it on the tangent line to solve c. It exists on both. So then if we plug in f of -1, we will get -1 cubed, because remember this is into the original function, like that, cubed, and then take away 3 times -1. So this will give us -1 plus 3, which is actually 2. So we're talking about the point, not -1, we're talking about the point -1 and 2. So now if we plug that in, y tangent is equal to m tangent x plus c. You can see the y value would be 2. The tangent we got was 0, technically, but I'll do it in full just so you can see how it works. Then -1 plus c, and so therefore 2 is equal to 0 plus c, and so therefore c equals 2. So therefore y tangent would be 0x plus 2. Now obviously, yes, you could just kind of immediately write y equals 2, but this is just to prove the way that those steps work. So y tangent is equal to 2. It means it's a flat line. So I've actually found it at a turning point. The normal equation at that point would be, technically we can just kind of jump in here. We can get m tangent is 0, so therefore m normal would be -1 on 0, which is actually undefined. So I've started off with a trick question here. Probably shouldn't have done that. And so if you have an undefined gradient, then it means that you've got x equals. It's just a vertical line, and that would be at x equals -1. So that would be it. So maybe what we'll do is pick another x value. So again, let's just write it over here. So f of x is equal to x cubed, take away 3x. This time we'll do it at x is equal to 2. So the first thing we would do is get our derivative. So 3x squared minus 3. Then we will plug in 2 to get the gradient. So that will be 3 times 2 squared minus 3, which is 3 times 4. We'll cut a few steps here, which is 12. Take away 3 is 9. And there's m tangent. Then we need to get the y value. So f of 2. 2 cubed, take away 3 times 2. And this will give us 8, take away 6, which is 2. So we're talking about the coordinate 2 and 2. And then we can plug in y tangent is equal to m tangent x plus c. So we can plug in 2 for the y value. The gradient was 9. X value is 2 plus c. So 2 is equal to 18 plus c. So c is equal to -16. And so therefore the y tangent equation would be 9x take away 16. Simple as that. If we wanted to get the normal, we can take the gradient of the tangent, and then we can just go, the normal would be -1 on that, which is -1 on 9. Be careful, the c value is not going to be the same, so you actually have to repeat that process. The coordinates are going to be the same, so we can just go y normal is m normal x plus c. We can plug in 2 and 2, like that, and our gradient this time is -1/9 plus c. So 2 is equal to -2 on 9 plus c. So c is 2 plus 2/9, and so then that would give us 20 on 9. So therefore y normal is -1 on 9x plus 20 on 9, like that. You can also see those factorized sometimes, so you might see the -1/9 pulled out the front. You'll have x minus 20. It's a little bit nicer. VCAR preferred to have as few fractions in the answer as possible. And so then if we jump over to a VCAR question, this one is from exam 1 in 2018. So we don't need all of the preamble from before, but find the equation of the tangent to y equals x sine x at this point. So already they've actually done a bit of the work for us. They've given us a, and they've given us f of a. So we don't have to go plugging in to get the coordinate, we already know it. We still, though, need to get the gradient. So I might not use function notation, I'll use equation notation now. So dy dx is equal to, now you can see this is a product rule, so we have to then go step aside for a moment, go u is equal to x, v is going to be sine of x, u dash is going to be 1, and v dash is going to be cosine of x. And so the derivative is going to be u dash times v plus v dash times u. So 1 times sine of x, so 1 times sine of x, plus x times cosine x. Like that. And then what we have to do is get the gradient at x equals -5 pi on 2. So here we're going to go let x equal -5 pi on 2, and the gradient should be, of the tangent, should be what you get when you sub that into the derivative. So sine of -5 pi on 2 plus -5 pi on 2 times cosine of -5 pi on 2, and now we have to do exact values from circular functions. So here, this would be 2.5 pi back, so then if we cycle backwards, that will land us at what is the same as -3 pi on 2, positive 3 pi on 2, and that gives us a -1, and then over here, this is take away 5 pi on 2 times pi, and then cosine of -5 pi on 2 will also land us at where positive 3 pi on 2 is on the unit circle, but cosine there is 0, so that gives us -1. Take away nothing, so m tangent is -1. Then what we do is we can skip this, because we already know that it's -5 pi on 2 and 5 pi on 2. We don't need to plug in. Now we plug those into our tangent structure, like this, and so we can put in 5 pi on 2 is equal to our gradient, which we got as -1, times -5 pi on 2 plus c. We get 5 pi on 2 is equal to +1, a lot of 5 pi on 2, plus c, so c is actually equal to 0. So therefore, the y tangent equation is going to be m, which is -1, x plus nothing. So really, y tangent is just -x. And there's the equation of the tangent. Simple as that. Cool. All right, that's all I wanted to go through in this one. So if you enjoyed it, then like the video and subscribe. If you want to see more, I'm going to try and put these up as frequently as possible. If you do want to see something really specifically, then let me know. Otherwise, I am going to go through some worked examples to past VCAR exams, including NHTs as well before the exam hits. But if you've got any requests, just let me know. Otherwise, I will see you in the next one.